Right, here's a question for you to do. So you've got points A, B and C, where A is 2, negative 1, 1, B is 5, 1, 7, C is 6, negative 3, 1. You need to find the area of triangle ABC. Now there's two ways of doing it generally. There's the standard geometrical approach using trigonometry, which you can do without using vectors, or there's the vectors approach, and we're going to do the vectors approach. Okay. If you need a hint, I've left the title of Scalar Product still there. Okay. Maybe just pause the video, have a go. How did you get on? What was the first thing you did? Okay. Did you draw a triangle? Okay. Did you draw a triangle? Label it like that. Now, if you didn't, why on earth didn't you listen to what I said in my very first video on vectors? When I said, and I believe I said this, make sure you draw a diagram because it makes things easier. Why didn't you do that? Okay. If you did draw a diagram, thank you so much for listening to that first video and well done. Okay. But more seriously, if you didn't, don't let that be a lesson to you. Try and draw a diagram wherever possible. Okay. I don't think there's ever been a lesson in vectors where I've not drawn a diagram at some point. Okay, because it's just needed. Right, so there's triangle ABC. I'm not going to put the coordinates in because they're there. Okay. So what have we got to do? What have we got to do? We've got to use the formula half AB sine C to do it. Okay. So that means is we need to work out an angle in that triangle and then two of the adjacent sides, two of the adjacent lengths. Okay. So I don't know which angle you went for. I'm going to go for that one there. And I'll call it theta. So what I need to do in this question is work out the angle theta. I need to work out that length, and then I can put them into the formula. Okay. So to work out the angle theta, okay, use the product rule. I'm obviously missing calculus. No, not the product rule, silly me. The scalar product. Okay, product rule. Never mind. Yeah. So let's just write down what AB are. Is a vector first. So AB, so 2. So that's 3. And negative 1 to 1 is 2. 1 to 7 is 6. Alright, so that's AB. And let's work out what AC is. And that's going to be, well, notice before I do that, that AB I put in as that, and AC I put in as that. Okay. You can see from the diagram, we would expect a acute angle. Okay. If it was obtuse, the arrows would be facing the other way. Okay, but it's an acute angle. AC is equal to, so 2, that's going to be 4, and then negative 1 to negative 3, negative 2, 1 to 1 is 0. Isn't it nice when you get zeros? Zeros are really nice when you get those in working. Obviously zeros aren't nice in a test, but it's nice when it's in working, isn't it? So let's just check that, okay, so amongst all my chattering, yeah, it's fine. Right, so use the scalar product then. So I'm going to write it out as this, 3, 2, 6, dot 4, negative 2, 0. So let's find out what that is. So 12, subtract 4, plus 0, that's 8. And then equal to the square root of, so that's 9 plus 4 plus 36. Oh, look at that, it's 49. Isn't that nice? Isn't that nice? Isn't it nice when things work out like that? Okay. So 7. A bit suspicious actually. I'm going to try it again. So it's 36, 4, 9, 44. Yeah, it is 7. That's good. And then this one is going to be 16 plus 20 plus. The hell did I write 24? 16 plus 4. I know I wrote 20 because I'm working ahead. The answer is 20, isn't it? So root 20. Okay. So yeah, 16 plus 4 root 20. That, okay, cos theta. Now before I go to the next step, notice how in doing my working for the scalar product I've found the length of AB and AC. It's in the working, isn't it? Okay, this and this. So finding the modulus of that in my working for the scalar product, okay, that has told me what the length AB is, 7. And this here, I've worked out the modulus of that, that is root 20. Which is rather handy, isn't it? Okay. So a lot of the work in finding the area of this is done in the scalar product calculations. Okay. Now let's just write that as cos theta is equal to 8 over 7 root 20. Okay. Now I'm sure that can be simplified. I'll use a calculator. Okay, that's 8 divided by 7 divided by square root 20 equals 4 root 5 over 35. Okay, so that's, do you mind if I just do that there? Okay, so 4 root 5 over 35. There's two ways of doing this next step, okay? So, you know, do you want to work out the angle and then substitute in? Fine. Or do you want to do it without you working out the angle? You can do it either way. Okay, let's just work out the angle, okay? So for your information, inverse cosine of that angle is 75.19 degrees. Okay, so what can I do? Let's just write it, let's write it there, shall we? Theta is 75.19 something degrees. Okay? If you're doing that, then just do the sine of that, so sine that angle, okay, 0.966, times by root 20, times by 7, divided by 2, 15.13, okay? So that means that the area has got to be 15.13 something units squared, okay? So that's one method. Not my preferred approach, that's one method. So what else could you do? Okay, you need to find what sine theta is. Do you know how to do that? It's 1 minus cos squared theta, isn't it? Sine theta is 1 minus cos squared theta. Okay, so let's just do that. Okay, so 4 root 5 divided by 35. Okay, and then let's just square that. 16 over 245. And then add on 1, subtract that from 1 I mean, 229 over 245, square root of that is, doesn't like that, does it? Why is it like that? Root 229 over 245, okay, so that's what sine theta is, okay, so for some reason my calculator won't root that and give me a nice surd form, okay. Probably because it can't really be simplified much. I'm not going to test it. Anyway, you just do that times by root 20 times by 7 and then divide by 2, and of course you got the same answer there, 15.1. Okay. My preferred approach, although if you want you can actually work out the angle first. Okay, right, hope that was helpful to you, hope you enjoyed that. Okay, let me just take a moment to discuss why the vectors approach is preferred. Okay, just take a metaphorical step back and just think about how much simpler that is compared to what we would have to do without using vectors. Without using vectors, what would you do? So here's the triangle. Hopefully you can see that, all right? You should be able to. So there's triangle ABC. How would you work out the area of that without using vectors? Well, you're going to have to work out the length of that side. Let's call it A. Let's not underline it because it's length. It's too busy underlining that. You have to work out that, and you have to work out that, wouldn't you? Okay. Now you can use that and that to work out A, and that to work out B. You have to use Pythagoras' theorem. But once you've got that and that, how are you going to work out that angle? You have to work out that side as well. So you're going to have to use Pythagoras' theorem 3 times to work out those. Then you're going to have to use the cosine rule to work out that. Okay, and then of course you can use the half AB sine C formula. Okay. Now, compare it with this, okay? Instead of using Pythagoras' theorem 3 times and then using the cosine rule, all you need to do is that. Do you see? You begin to understand why vectors comes up so often now, okay? You'll find that the vast majority of geometric problems can be solved more quickly with vectors than with either the Pythagoras theorem or the trigonometry, the non-vector approaches, okay? And that's why that's a major topic at university, okay? I'm hoping that example sort of illustrates that for you, all right? Hope you enjoyed it, okay? Hoping you're starting to like vectors a lot more, okay? I kind of like it's fun, okay? I didn't wake up this morning thinking, right, yeah, let's do vectors, okay? But, you know, when you get into it, it's like, it is kind of fun. Hope you find it fun as well.